Hey guys, welcome back to my YouTube channel Coding Ninja, and today we are going to be solving this daily liquid problem. This is problem number 1035, uncrossed lines. So let's just read through it, and today's date is 11th of May, and this is our daily liquid problem. Now let's just have a read through it. You are given two integer arrays nums1 and nums2, and we write the integers of nums1 and nums2 in the order they are given on two separate horizontal lines. We may draw connecting lines as straight lines connecting the two numbers nums1i and nums2j. So these has to be different numbers since they are being represented by two different integers I and j. That's fine. Such that nums1i is equal to nums2j. The line we draw does not intersect with any other connecting lines. Alright. Note that the connecting line cannot intersect even at the endpoints, i.e. each number can belong to one single connecting line. Alright. Now return the maximum number of connecting lines we can draw in this way. Now it might sound a little complex at first, but if you try to think about it, it is essentially the maximum longest subsequence. Basically, yeah, the longest subsequence problem. It will be given in two strings. If you just think about it, like basically they are two strings, so it could be A, B, C, and then it would be A, C, B. So basically, yeah, the longest substring will either be like as it is shown over here, 1144, or it could also be 11 and 22. So yeah, it basically boils down to that. So that is quite a well-known problem in the dynamic programming. And basically, what we do is we get two arrays. We just check. We get a 2D array of n plus 1 and n by n, and we basically all we do is we check if the two characters that we're checking are the same. If they're the same, we do +1 to the previous value, so which basically is I minus 1 and j minus 1, and otherwise we do a maximum of one item above and one item to the left. So I hope that is clear. Now let's get into the solution. So first what I'll do is I will get the length of nums1 and nums2 into two variables, and I'll get two variables I and j, because we will be using them to iterate over these arrays. So let's just do that. So int I is equal to nums1 dot length, j is equal to nums2 dot length, and then as I mentioned, I'll require two variables I and j. Now next step is we create a new array. This will be storing our dynamic programming solution basically. So this will be int 2D array dp is equal to new int n plus 1 and n2 plus 1. So instead of declaring it by n1 and sorry, this is not I and j, this is n1 and n2. This will be n2 and this will be n1. So instead of declaring it of the length n1 and n2, I've declared it as n plus 1, n1 plus 1 and n2 plus 2, n2 plus 1, because we just get rid of the zeroth row. We don't need to have a special condition. We'll just have zeros up top, so we can take advantage of that. So I'll start with the actual solution then. Then I'll have a for loop. So for I is equal to 1, since we don't really have the zeroth place, actually we are just looking for the zeroth position, which will have basically zeros as a placeholder, and we don't need to take care of it as a special condition, where like normally you would do is like if I is equal to 0, then put it as 1. Instead we can just do the plus 1. Now I'll do another j is equal to 1, j is less than equal to n2, and I'll do j plus plus. Now if we just do an if statement, so basically we'll do if nums I minus 1, since we are not considering the zeroth position, so we are starting at the ith position, but we want to compare the arrays at the zeroth position as well, and it will be nums2 j minus 1, and this will be nums1 I minus 1. So basically what we'll do dp I comma j is equal to dpi minus 1 j minus 1 plus 1. So as I mentioned, so we'll be just adding 1 to the top right position, and the other would just simply be a simple else, where if this condition is not true, we want either the max from the previous statement or the statement prior to that. So max, so it will be a dp I minus 1 comma j dp I comma j minus 1, and we'll do nothing on that. We don't need to add anything. And for the return statement, we will just return the last element, so which should be dp n plus 1 n1 comma dp n2, and that's pretty much it. So if I run this solution, let's see, and that's correct, and let me do a submit as well, just to see all test cases are working, which they are. So yeah, so if you know the longer subsequence problem, like, it becomes extremely easy solution. And if you still don't get it, I'll just show you the diagram they showed in the tutorial, because that is a really good way to see it. So basically, what we are doing, we are solving for this arrays n1 and n2. Actually, the length of n1 and length of n2. So if the numbers are equal, basically, that's basically what I did. So I went and to the left side. Let me open an Excel and I'll show it to you how it will actually look. So just a second. So basically, what was the first question? Okay, so this is a problem 1 4 2 1 2 4. So basically, what is we doing? Basically, what are we doing? So we are declaring a 2D array of 4 by 4 matrix for this problem. Now, actually, let me write it over here so I can write the indexes above that. So this would be my 4 by 4 matrix. So this will be 0th position, 1st position, 2 and 3. It will be 0, 1, 2 and 3. So by default, the whole array would be a 0, 0. Now, when we come over here, we check if these two positions are the same. So yes, these two positions are the same. So we are checking for 1, 1, I is equal to 1 and j is equal to 1. So yes, nums 1, I minus 1 and nums 2, I minus 1, j minus 1 are the same. So basically what you do is a 0 plus 1, which comes out to be 1. Now we are comparing this 4 to this one. Are these the same? No, these are not the same. So basically this will be a max of this and this. Actually, just a second. Yeah, so basically, yeah, it's a max of the previous two solutions. So like either this or this. So this comes out as 1 and this will also come out as 1. All right, now if we go over here again, so now we are coming to the second position. Now we are comparing 2 to 1. So is this the same? Yeah, no, it's not the same. But we'll have 1 over here because we are comparing 1, 1 and this. So this basically gives us the solution of 1 as of right now. Now coming to this position is 2 equal to 4. No, it's not equal to 4. So we'll basically do a math.max and this will come out to be 1 again. Now coming to this position. Okay, so now we have a match. So 2 matches this. So basically what we'll do, since we know this is a match, so whatever is in the previous plus 1 will be our solution. So these two are matching. So previous plus 1 is, so basically 1, 1 and 4. So basically that solution is this one. So we'll do a 1 plus 1, that would come out to 2, and similarly we'll be filling our array subsequently. So in the end, this will become 1, this will have math.max of this. No, actually not math.max, it will be a plus 1 to this. This will be a 2, then this will be math.max, so this is again a 2. So I hope you guys understand this problem, and if you don't, you can read up on the maximum common subsequence problem more on the internet. It's quite a famous problem on in dynamic programming, and if you still don't get it, you can leave some comments. I'll be happy to help you guys out. I hope you guys like this lecture, and that's it for today. Thank you. Have a nice day.